Okay, today you're going to be learning about circles and mainly about the measurement of circumference, which is the perimeter around a circle. We're going to start with a video.
Hi, welcome to Math Antics. We've learned a lot about geometry so far, but there's one really important geometric shape that we still need to cover, and that shape is a circle. Since the invention of the wheel, circles have been extremely important to all humanity. Grog made wheels. Thanks, Grog. In fact, you probably see circles almost everywhere you turn. But mathematically, what is a circle? Well, in geometry, a circle is defined as the set of all points that are equidistant, or the same distance, from another single point. And the best way to understand what that means is to see it in action. So, here's a single point to start with. And now, let's start drawing points that are equidistant from it. This point is a foot away to the right. Now let's make another point a foot away, but in another direction. Let's say up here. Now let's make another one, also a foot away, but in another direction, right here. Now let's make another, right here.
And another.
Phew, I'm getting tired. But do you see what's happening? The more equidistant points we add, the more the pattern looks like a circle. And that's why a circle is defined as a set of points that are equidistant from a center point. But of course, we usually don't see it as a set of points because there's infinitely many of them, so they form a continuous circle. Okay, now let's learn about the parts that make up a circle. First of all, we have the original point that we started with. That's called the center, or the origin of the circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle. That distance is called the radius. The radius is important because it's the distance from the center of a circle to any other point on the perimeter of that circle. And even though a circle only has one radius dimension, you can draw as many radius lines as you want to. Usually you'll only see one radius line drawn, since it's the same length no matter where you draw it. Another important circle dimension is called the diameter. The diameter is the distance across the circle. If you start at one point on the circle, and then draw a line straight through the center to the other side, that distance is the diameter. As you can see, the diameter is really just the same as two radius lines drawn in exactly opposite directions. So for any circle, the diameter is always exactly twice as long as the radius. All of the equidistant points we drew combine to form the perimeter of the circle. Remember that perimeter is just the distance all the way around a shape. But because a circle is a special shape, the perimeter of a circle gets a special name. It's called the circumference. The circumference is the distance all the way around a circle. We're going to learn how to calculate the circumference of any circle in the next video. We'll also learn how to calculate the area of any circle. But before we can learn those things, we first need to learn about pi. Grog made pi. Sorry, Grog, not that kind of pi. In math, the word pi, which is spelled P-I, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? It's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about it. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. 2 diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close. 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat.
I'm confused.
Yes, irrational numbers are confusing, but seeing some more of pi's decimal digits will help you understand what I mean. To be more precise, pi is 3.1415925397897932338, and the decimal digits just keep on going, forever, without repeating. Pretty amazing, huh? But the good news is that saying pi is 3.14 is usually close enough for most math problems, so that's all you really need to memorize. And that's why we use a symbol for pi in equations. We could write pi with just 2 decimal places, or we could write it with 5 decimal places to be more accurate, or we could write it with hundreds of decimal places to be super accurate, or we could just use the symbol to represent the true value, which is infinitely accurate. Okay, so in this video, we learned what a circle is, and we've learned about the important parts of a circle: the center, the radius, the diameter, and the circumference. We've also learned about a very special number called pi. Pi is the ratio of a circle's circumference to its diameter, and its value is about 3.14 no matter what size the circle is. In our next video about circles, we're going to learn how we can use the number pi to find the circumference and the area of any circle. And even though there's not much math you can actually practice in this section, don't worry. There'll be lots of practice problems in the next section to make up for it. Thanks for watching Math Antics, and I'll see you next time.
We're all good at math.
Okay, so let's give this a try. We'll again define some of the parts of the circles, and then we'll try a few problems. So if you recall, the line that goes through the center of all circles is called the diameter. So you might want to write this down. The yellow line that you see there, from the center of the circle out to a point on the circle, is called the radius. And the distance around the circle is the circumference. And the value of pi for any circle is always just over 3 times bigger than the radius. So if you want the exact number, you use the symbol. Because we can't write it exactly, it's irrational, meaning it never ends and never repeats. And here's just a few of the digits, right? Because it's only it ends at about 200 decimal places, but again, it's infinitely many. And they have supercomputers that are still calculating the next digit of pi as we speak. So it's a ratio, actually, where you take the circumference and you divide it by the diameter. It's how many times the diameter fits into the circumference of the circle. And what they found is that it's kind of a constant for every circle. You saw on the video, the small circle and the large circle, you take the diameter and put it around there, and it goes 3 and just a little bit more, and that little bit more is that decimal part of pi that we can't quite pinpoint. But so it's a very useful constant in calculating things like circumference if we know the diameter, because we can approximate pi and therefore approximate the circumference. So pi is equal to the circumference divided by the diameter, and if we rearrange these, remember using a little bit of algebra skills, and we say, if I multiply both sides by d, I could get rid of, d in the denominator, and then I could divide both sides by c, and what would I get? So we rearrange it so that to get the circumference, you would take diameter times pi. So let's try some. If we use 3.14 to find the circumference of the circle, and they give us the diameter, so start with the formula, diameter times pi, or pi times diameter, and substitute in the values, 3.14 times 8, and if you round it to the hundredths place, you would get 25 and 12 centimeters for the circumference. So make sure you're trying these problems as you're writing them down in your notes to make sure you understand where these solutions come from. Okay? So what if we are given the radius? Remember the relationship in the video was that the 2 times the radius is equal to the diameter. So we can also substitute this into our original formula. Since we know that pi times diameter, we can substitute in that 2 times r for the diameter. So a lot of times they write the formula like this. Circumference is equal to 2 pi r. So 2 times the radius, which equals the diameter, times the value of pi. So for the next few examples, we're going to be using either the diameter or the radius to calculate circumference. So in this one, we're given the diameter. So again, formula is diameter times pi, so 4 times 3.14, and you get 12 and 56 centimeters. Make sure to use your label. This is the radius, so we have to take 2 times the radius because we know the diameter is actually 18 meters. And we'll get 2 times 3.14 times 9 is 56 and 52 hundredths meters. Again, with the diameter. Now if I'm going too fast, make sure that you pause the video and record these. If the diameter is 23 millimeters, you want to take pi times 23, and you'll get 72 and 22 hundredths millimeters. And finally, if you're given a radius of 58 centimeters, remember that is 2 pi r for the formula. So 2 times pi times 58 is equal to 364 and 24 hundredths centimeters. What if they give us the circumference? So notice in this circle, the distance around the circle is 12 centimeters, but we need to know the radius. We can use this formula because it's the formula that relates the circumference and the radius, because it's 2 times pi times the radius is equal to the circumference, and then we can rearrange it so that we get the radius by itself, right? So if we divide both sides by 2 pi, so circumference divided by 2 times 3.14 will give us the radius. So the circumference is 12, 2 times 3.14 in the denominator, and if you solve that, you get 1.91 centimeters is equal to the radius. Okay, this time finding the diameter given the circumference. So it says use pi to find the radius of the circle, but I think they're wanting us to find the diameter, so actually this should be just to be consistent, okay? So this is what we're going to do. So we're going to start with the formula that relates pi times diameter. Again, divide both sides by pi by rearranging it, and get diameter is equal to the circumference divided by pi, and that will give us the diameter. If you're ever asked to find both, you could take the diameter and divide it by 2 to find the radius. But in this case, 47.1, the circumference, divided by pi, 3.14, is equal to 15 centimeters. So that would give you a radius of about 7.5 centimeters, and it's okay to have decimal measurements. Okay, it's now time for you to pick up your worksheet and start working on homework so that you can practice these concepts.